This video discusses exception errors or validating data. As you learn to program, it is extremely important to include exception errors in your program. If the user of a program enters the wrong type of data, the program needs to indicate that the wrong type of data or data type has been entered. Otherwise, the program will crash on the user. The goal is to write programs that do not crash, so you want to avoid the program from crashing. Suppose the program requires a user to enter positive values. Instead, the user enters a person's name or they enter a negative value. Then, code must be added to indicate the wrong data was entered and the user must re-enter the correct data type. We use loops to facilitate this process. Loops are used to enable the user to enter correct data. That is, it's repetitive. If they use the wrong data, it's going to say go back and enter it again. That's a repetitive operation. Let's use the gross pay version program. We will check to see if the user enters the value, a numerical value, or if what they entered is greater than 0. We're going to use the Raptor program because in Raptor there's a special function called isNumber argument or isString. So again, in Raptor we have this special function called isNumber, and it's going to check to see if the argument or that variable, if it's a number or if it's a string value that you entered into the computer. Okay, we're going to use our gross pay program that we have been working with in the past. This is the one where we were able to tell the computer to write the output to a dedicated text file. We're not interested so much in string data at this point. What we want to make sure of is that the computer has the right data, like hours worked and the pay rate. For example, if I run this program and I put in James Johnson and I put in 40A, and for the hourly rate I put 75C, I'm going to get an error because what's happening is the computer is checking 40A against 40 and they do not match. Furthermore, A is a character data or alphanumeric, so we ended up with a type mismatch error or a string error. We're comparing a string kind with a number kind, and that's a conflict, and so the program actually crashed. It would also crash if I put the 75C as the value for my pay rate. So I've got to put in a statement, a loop. As soon as the user enters the hours worked, I need to have a loop in here that will check to see what they entered. So I'm going to say is number hours worked. I'm checking to see if is this hours worked. Now the way my loop is, because I changed it, I reversed it, is checking to see is number hours worked. Yes. If no, just go out to the next item. So I'm going to negate this by using not. Not is a logic operator. I'm going to say if this is not, I'm going to put the not right in front, and I'm going to enclose that in parentheses on both sides. Let me make sure I don't have a double parentheses because this is so small. The way the computer interprets this, it says if hours is not a number. That's how the computer checks that. Checks to see if hours worked is a number. If it's not a number, that's how it's checking it. I negated it because the yes is going in the forward direction and the no is going to the left. If hours worked is not a number, yes, that's the case, then I need to go ahead on and re-enter the hours worked. I'm going to add something else to that. I'm going to say wrong data type. Re-enter as a numerical value. I know it's kind of long, but when you're learning this, it's better to spell things out than to take it for granted, so deal with it. Okay, wrong data type, re-enter as a numerical value. How many hours did the employee work? Okay, so let's run the program again. We're going to run Henry Jones 40B. See, and it says wrong data type, re-enter as a numerical value. It will not let you move forward until you enter the correct data type, which is numerical. So I will put in a 40. And now I can move on to, I put in the 40. Oh, let me just change this so it shows here. So once the information has been entered, since this results were sent to a file, we have to go to the folder or the directory where the information was stored. It created the last name, first name, employee out. And here's the information. Hours worked 40, rate of pay 75 per hour, gross pay $3,000. So it shows this information as such. The program will crash if we do not enter the right pay rate. So we will need to add a loop to do that also. And so we're going to say not is number pay rate. Make sure you spell the correct variable name. And we will also enter, you want to re-enter the correct pay rate. And so we're going to add wrong data type again. Re-enter as numerical value. Okay, let's make sure that I close this off with a double quote. That happens sometimes. We're going to run the program one more time. We'll still put in Henry Jones. This time he worked 55 hours, but I accidentally put in 55A. It is going to tell me, please re-enter the data as a numerical value. So I'll enter 55. How many hours did he work? What is his hourly wages? It is $75, and I accidentally put in an A there also. It is going to tell me, please re-enter the data correctly. Re-enter as numerical value. So I'm going to put in 75. Okay, now the reason why this isn't going to work is that I did not add not. Remember, because the yes is going in this direction, so I'm going to have to say, if this is not a numerical value for hours worked, I'm going to do the same thing. If this is not a numerical value for the pay rate. Now, I accidentally changed the variable name, so this was correct. The not was included, but I put in pay underscore rate. And it's a good thing that this happens. This is a typical error, so you want to make sure you enter the right variable name. If you don't, it is not going to work correctly. Let's go back and re-enter. Henry Jones 55A. Nope, that's wrong. It needs to be a numerical data type. 75C. Wrong data type. I'm going to enter 75. And now it says it was complete. Now, as a new programmer, it might be good for you to even place a message at the end of your program to say that data file has been written, the output has been written to the data file and not on the screen, so go to the data file to look for it. Because sometimes students look for the file and the output on the screen, and that's not what we told this program to do. We said for it to write the results to an output file. So we're going to go to the output file where it was written. Here it is. And now it's a little bit different because we have overtime. Overtime hours, overtime pay, regular pay, and then the gross pay. But it wrote the results to an external data file. Okay, so this is the illustration using Raptor. I did not use Flowgorithm because Flowgorithm already allows for, if a student enters the wrong data type, it's going to automatically say this is wrong. But in the Raptor, it's we show you the whole logic and the design, the algorithm behind this. We need to also check to see if I entered a positive number or not. So we're going to go in and say, if this is not a number, or if hours worked is less than 0. So either one of those is going to cause the computer to ask the user to re-enter the data. So we're going to do the same thing here. If this is not a number, or what the person entered is not a number, or, got to write that or, that's a logical operator, or the pay rate is less than, and we better say less than or equal to 0. Let's add the equal to that, if it's less than or equal to 0. I always like to enclose my conditionals or criteria in parentheses, so let's go ahead on and do that. So now we added another criteria with that, so it's compounded. We're checking to see if the number, if it's not a numerical value, or if the value that the user entered was less than or equal to 0. Let's put less than or equal, because we do not want to enter 0. That makes no sense. We do it also for checking the pay rate. If this is not a number, or the pay rate is less than or equals to 0. Let's run the program again. I'm going to enter someone's name. We'll say Mary Smith. She worked 60 hours. I accidentally put an A there, so we're going to go back and put 60. And I'm going to put in a negative 55, and it says wrong data type. But actually, it's not just the wrong data type, or it's a negative value that was entered, so we can add that also. But at least it flagged you and said, no, this is the wrong information, so I'm going to put in 55. And now we go to the folder where this was stored, and now it says Mary Smith, 60 hours, rate of pay $55, and so on. So to indicate that we want to enter a positive value, we should say wrong data type, re-enter as a positive numerical value. And we do it for both of the conditions. Okay, so that's the logical design. Visually, this is what is happening. Now we're going to show it to you using Python. So stay tuned for the next video concerning Python.